My name is Aimee Barciauskas, and I'm a data engineer with Development Seed. And I actually pulled this slide from a previous presentation that I've given on the Muir SST sea surface temperature data set. So a little bit of like historical background. I got introduced to Shel Gentman, who probably many of you know, who's another oceanographer who's been involved with OceanHackWeek this year in the past. And I met her at this Explore Science SMD NASA Science Mission Directorate workshop in 2018. And that's sort of how I got at all involved in OceanHackWeek, was working with her on the Muir SST ZAR dataset, which I believe was used for one of the projects last year. So I sort of knew about OceanHackWeek last year and was fortunate enough to still be sort of part of the ecosystem this time around and get to work with this tutorial. So yeah, I'm a data engineer or data team lead at Development Seed. I live in Seattle. Science curious, but not a scientist. I felt important to make that clarification since I'm not as much an expert in some of the ocean science, but that's why I'm excited to be here, because as a data engineer, I always love to hear more about the actual science that the data is supporting. And my day job, I support biomass research through the multi-mission algorithm and analysis platform. And yeah, I'm passionate about open science and cloud-based tools. To support it, see past work on the Muir SST ZAR store. Cool, so I'm gonna jump into the tutorial now. And as was true with the previous tutorial, please feel free to jump in if you have questions, or Nick, if you see any questions, I guess, in the chat, to yeah, just chime in with them. So this is going to be on data viz in Python, and we're going to be using the Jupyter Hub, so you can go ahead and follow along if you're in the pilot 2i2c.cloud interface. You should be able to follow along in the OHW tutorials directory. So I'm going to navigate to the data viz tutorials. So I'm going to navigate to specifically the data viz tutorial directory, and there is an index file there that I'm going to use to get started. And is my font size okay for everybody?
Could you just make it a little bit bigger? Just
Yeah.
maybe one more, and hopefully that'll be good. Yeah, that's much better.
Okay, cool. And then I can close this side panel. So we're going to be talking about a number of different libraries that support data visualization in Python. And as was mentioned in the previous tutorial, and I'm sure other tutorials, since we only have so much time for this tutorial, I just want to make sure that we start to get a lay of the land in terms of what's out there available to doing data visualization in a notebook. And there's even, of course, more out there that we won't mention, but so we know where to go to find more information or more examples in the future. So in this particular tutorial, we're going to be looking at using Panel, HVplot, HoloViews, GeoViews, DataShader, Param, and ColorSet. So this is sort of the schedule. I don't necessarily anticipate we'll get through all of this, but I think we can cover a lot of it, at least in terms of the non-exercise notebooks. So we're going to skip the setup and we're going to start by going through the overview. So to motivate why HoloViz and why like this set of tools in particular. So as you all know, as scientists using the notebook environment, there's all these different steps like import and cleaning, initial exploration, testing, hypothesis, and data visualization. One thing that certainly I've come to realize as a data engineer is that it basically data visualization can help with all of these steps. And in the spirit of like sort of reproducible science, I think it's also helps to have these data visualization tools and libraries handy, like at our fingertips, so that when we're going through creating notebook to sort of motivate the science that we're doing, it explains like, oh, we did this exploration of the data, and it navigated us in this direction. So including those figures in a reproducible way using these tools is really, I think, what makes all of this powerful. So yeah, so there's this question, doesn't Python already cover all of these stages? And that's why we ended up with this, sort of crazy looking Python landscape. I should also mention, I forgot to mention that, if you were part of OceanHackWeek 20, you might find these, I like to think that this is one of my qualities as a good software developer, which is that I like to reuse things. So this is probably going to look familiar, but we've updated it with an oceanographic data set. So there are some updated examples in these notebooks. So HoloViz helps with this crazy landscape by focusing from the start on tools that support web browsers fully, because all tools offer static output, and it focuses on writing Python, not web tech. So again, this is like why HoloViz is a good framework to use as opposed to just using a native visualization interactive library like JS or CSS, because we can use it within our notebook experience and enable other Python developers to run it there. It also helps with browser-based data size restrictions. So we're not limited to working with smaller data sets. We can start to use some of these tools that are actually more mature in dealing with large data problems, and make sure all the interactivity works the same in Jupyter and in the standalone environment, and provides high level, quick and convenient interfaces that are shortcuts, not dead ends. So yeah, with that, I think, so just to go over again what those libraries are, we're going to start to look at today. We have Panel, which is for basically, creating objects that can work with the assembling objects from many different libraries into a layout. So it helps us assemble basically things into a dashboard type interface, the same way that you can use with, I think it's RShiny. So the same way you can create like an RShiny dashboard that has different components in it. Panel helps us do that. HVplot is really great for all of those data structures that we're working with now from Pandas and Xarray. That those Pandas and Xarray data frame data structures, we can create plots directly from those using HVplot. And then we can use HoloViews to build those fancier bokeh plots, bokeh, I think bokeh is how you say it. GeoViews is for the geographic data to mix that in. Data Shader helps with visualizing larger data sets, rasterizing larger data sets. Param helps us declare different parameters that users can configure. That helps with some of our interactivity in our panel environment, but dashboarding experience. And then color set is creating perceptually accurate continuous categories. So color sets for creating those legends, those different color variations. And so again, we're integrating with these other Python scientific ecosystems. That's another reason why this set of libraries is appealing to us. And yeah, so now we're going to jump into some tutorials unless there's any questions.
No questions yet.
Okay, cool. So the first tutorial is building panels. So we're going to use panel to basically, and I'm just going to go ahead and run, I'm going to use this run all cells command. So we start to go through this set of steps. So first thing I just want to mention is the data that we're actually using here is if we go into the load data function is netcdf files from the NOAA Coast Watch on wave heights. So this is just wave heights basically for the year of 2021. So we have here 764,000 observations. And for all of those observations, we have wave height, wind speed, and gust. There's other variables available that we can inspect by going to this page and pulling those through, but those are just the ones that we're pulling into this particular exploration. So it's just a note about the data itself. We have latitude, longitude, and then we're basically going to build a PN interact object so that we can start to basically have an easier way to go through and like start to basically explore this data other than having to load the whole row into our Jupyter notebook. So that creates an easy way to explore the data within our notebook. And then basically we can create different ways to lay this out with panel columns. So we can lay it out in a different structure using panel columns and panel rows. And as you scroll through here, now we have a different sort of interface for doing that. So the different component types that we have are a pane. A pane provides a view of an external object, such as, and it can be anything like text, image, plot, etc. by wrapping it. A panel lays out multiple components in a row, column, or grid, and a widget provides input controls to add interactive features to your panel. And then there's a link to the reference gallery. So we can use text, we can have our data frame, and then I've just created a simple table here that lists the top 5 wave heights, so we can sort of create a dashboard experience that's going to report the most major waves, in this past year, basically from this data set. And I've gone ahead and inspected that those waves are near the Rat Islands in the Pacific. And then you can create sort of a more fully a more sort of complex dashboard layout where you have a row and 2 columns displaying the different rows and the top 5 or top 10 in this case with the NOAA logo. And then we can also update the content by inserting things into the column. And we can serve a panel app into a browser as well using row.show. And that's not going to work in this notebook environment, but would work if you were running this Jupyter. If you're running Jupyter notebook locally or on another web host, you could serve this as a separate web app with row.servable. Okay, cool. So now that we have our panels, there's another notebook. This is a shorter one as well for interlinked panels. And again, I'm going to run all cells. So what this demonstrates, this is a sort of shorter tutorial basically about, I'm going to load in the same data, and it basically shows how you can update data using callbacks. So the depends API is still a very high level way of declaring interactive components. panel also supports the more low-level approach of writing callbacks in response to changes in some parameter, e.g. the value of a widget. So all parameters can be watched using the param.watch API, which will call the provided callback with an event object containing the old and new value of the widget. So we can do that by basically creating a widget that's in a slider, another slider widget. And at first we're creating a panel that's just going to basically use the row slider.value. But then we can also create a callback that basically based off of the row slider.value, we pass it an event, and then we create the row slider parameter and watch the callback so that we update the actual value of the we will update the value of the actual panel with whatever row that we've selected with our slider. So when we go through and we scroll through this slider and we're selecting basically different rows, then this row slider thing gets updated using this callback. So whatever row we've selected here basically is this slider is watching that change event, and then it's going to make this callback and update this data frame based on that callback. Okay, so then we're going to move on from panel to perhaps something slightly more visually exciting, which is basic plotting using plot and HVplot. So with this, again, I'm going to run all cells. So many of us are familiar with the pandas data frame, and so we've used the plot API, which uses matplotlib to render static PNGs or SVGs in a notebook using the inline backend. However, we can also use HVplot for interactive plots and also working with larger data sets. So that's what we're going to do here. So again, I've loaded in the data frame that I mentioned, and I've also just mentioned, included here a note of the geographic extent of these waves. So you can see we're covering a lot, but not all of the globe with these wave heights. Just to note that we will be visualizing like a almost global extent type of data set. So we can use the pandas plot on this with a smaller data frame. So I've created a data frame that is just 10% of the original data, and then created a scatter plot. So now we can see where sort of geographically those so we're just using plot at this point to see geographically like where the density of those wave heights are. And then we can use HVplot to start to use HVplot to also visualize this data. So here, unlike the pandas plot, there's a default hover action on the data points to show location values. So now we can sort of hover over these. And I'm trying to see if, oh yeah, so we get these interactive tools as well. So now I can also zoom in to these plots and start to get those data values. You can see there's probably multiple of them here. So I'm using the alpha value to basically showcase density. And so if we zoom in, you know, there's fewer points in particular places. Okay, cool. So you might have noticed that many of the dots in the scatter that we've just created lie on top of one another. This is called overplotting and can be avoided in a variety of ways, such as making the dots slightly transparent or binning the data. These approaches have the downside of introducing bias because you need to choose the alpha or the edges of the bins. So we can use the hex bin option as an alternative here. So that's what we've just done. And again, you get the interactivity of being able to hover over these plots and also zoom in and see how many points are being represented in any one particular geographic location. And then here we're using data shader. So again, this is to avoid some of the problems of traditional scatter point plots using data shader, which aggregates data into each pixel without any arbitrary parameter settings. So in HV plot, we can activate this capability by setting data shade equal to true. So here, if we yeah, so here basically we're just getting all the points aggregated by color. So now we're getting a higher density is represented by color as opposed to, or sorry, this is also being represented, the darker color is the higher density. So here it's just aggregating it by color as opposed to the hex bin shape. Okay, and then there's also a note on points. So as y'all might have noticed as scientists, we probably want to use points instead of scatter because scatter implies dependency between the X and Y, which is not necessarily true. In reality, this is not the case as waves can happen anywhere on Earth's two-dimensional surface. So for this reason, it is best to use HV plot.points. And so then we're going to create some statistical plots. So with the statistical plots, probably y'all have used plot.hist. This notebook demonstrates how you can use on a larger data frame. So here we're just using a small data frame that's just a pandas, a pandas data frame of 10% of the original points. And here we're using HV plot, which can operate on larger data sets like I've demonstrated here. We're plotting a histogram of the wind gusts and passing some parameters. And then we can also use pd.cut to create categorical variables. So we might want to compare, we might want to take two of these variables such as gust and wave height and sort of compare them in a more complex histogram. So here we've categorized gusts as tame, gusty, and blown away, which are obviously very scientific classifications. And so then we can basically create a histogram again of wave height, but also colored by gust class. And so then we have the gust class in our legend, and you can start to explore for wave height, what is the breakdown of the different of how gusty basically those waves were as well, which is a wind speed classification. Cool. All right. And then finally, there's an example of using bivariate. So here, this bivariate, because of the size of this text now, okay, here we go. So we can select the different classifications that we've given. And then we get a density. So for here, we get a density of the highest density wave height and the gustiness of that. And sort of to visualize the data like this, this is also very interesting because you get a multi-centroid density plot here for some of these other classifications, which is interesting. Cool. All right. We'll just keep going unless there's any questions.
It looks like there's one question, but we could probably address it at the end of your slides, talking about the difference between Altair and HV plot.
Okay, cool. So far we have generated plots using HVplot, and this is basically showing how we can compose multiple of these things that we've just learned about. So with PN interact and HVplot. So I'm going to run all of these cells. So this is going to also show us how to map this. So getting into using actual map tiles with some OSM tiles. So here we've loaded in the data. Here we've loaded in the data again, and we're just going to basically create some time series plots, and then we can put those two time series plots together. So we have the weekly mean wind speed alongside the count of waves by week. And there's a very simple API for how to do that. And what's nice here is we can just sort of start to specify these things with operators that we're very familiar with. So this is where it gets into this aspect of the HoloViz framework that makes it very easy with like simple Python to do to basically display these plots. So we've created two plots and we're not faced with some funky thing of how to display them next to each other. We just do the plus sign and then call calls in one. So that's pretty cool. And then we can add a third dimension. So here we're going to add the third dimension of gustiness. So where we have, I skipped over the place where we create the most severe variable. So where did I do that? Sorry to scroll. Okay, right. So the most severe with gusts greater than or equal to 10. So we're starting out by just plotting all the most gusty wave heights. And those are visualized just in black and white. And then we're going to be using so then we're using HVplot scatter to visualize those things. So we get a different color scale there. But now we're basically going to use the color set library to create a different color legend. So we create a wind speed map. And then we're going to include that wind speed map with, actually this should be, oh, right. So this is just the wind speed, or sorry, just the gustiest wave heights. And then we're coloring them by wind speed, which actually should be, I think actually I've noticed an issue with this. This is probably should be mapping to the gusty variable and not the wind speed variable. So I might need to update that. But finally we get the hollow views. Okay, so finally we want to put all these points on a map. So we're using this tiles library to import OpenStreetMap tiles, so that's OSM. So from HoloViews, we import those OSM tiles and we can put those on a map. And then we're basically taking the XY is the longitude and latitude from our most severe data set that we've just created. And then we can plot those on a map with their severity colored by that color map that we've just created. So yeah, and then finally we can go into the exercises and probably won't go through all of the exercises today, but we can definitely start with the building a dashboard. So I'm going to so one of the data sets that was used last year was the earthquakes data set. And so here we're basically going to be pulling that data set from, we're going to be pulling that data set from S3, I believe. Actually, I need to look again. There is that data set on S3, but oh, USGS. So we're going to be getting some earthquake data from USGS. And right here, I'm only, for this purposes of this tutorial, I've only been pulling data from 2000 to 2002 to make it sort of run quickly. But there's two ways we could sort of adapt this example, which is to run it for more years. But I'd also be interested in adapting it for, again, a more oceanographic use case. So this building a dashboard basically goes through this building a dashboard, and the other exercises go through and show us how to basically use some of the things we've learned about with the panels, for example, to display a dashboard of earthquakes and overlaying that with the population data set. So I'm just gonna go through some of these exercises, but basically here, we're repeating this example of how to use panel to display a logo. So this is the data set, in this case is coming from USGS. Here we can use, I think it's pane and .latex. So this is using latex, so we can also display latex, which is cool for many of our use cases. And then we can create a data frame to display the strongest earthquakes. So here, this will just be pane, strongest earthquakes function. And see if I got that right. Panel. So here we have the strongest earthquakes for these 2 years that I've selected data from. Excuse me. And then we can display an iframe of a Google map. So I'm just going to, let's see. An iframe. Oh, I actually think I don't have the solution for this one. So if anybody knows what the solution is, exactly what the syntax is for doing this, I would take that. So it probably is something like panel iframe. So we can look that up. And then this one is basically a violin plot. Of the magnitudes as well. Yeah, so I think I will leave going through those as an exercise as well for users. But yeah, I don't know. Are there any questions or things that we should go over again?
I don't see any more questions. I guess we can circle back to the one question about the difference between Altair and HV plot if you have any insights about that. I see Philippe did put some comments about how Altair is opinionated, and plotting you can do in the input data format. However, you can be very quick and nice plots. So I don't know if you have any thoughts on that.
I don't know, Felipe, do you want to speak to that, to the group?
Yeah, I can elaborate that a bit more. Altair, if you have a data frame on the right format and you want to do those very specific data science plots that it does, it's great because it's very concise and short. It's based on the DT library and it's a subset of that. Holovis, on the other hand, is more like Matplotlib, or maybe kind of in the middle. You can do anything you want, but you have to write the code. There is even a joke by Altair's author, Jake van der Plat, that he said, I can do any plot with Matplotlib with giving enough time. And by making that joke, he means that it's complicated sometimes, but you can't really do anything. So Altair is one end of the spectrum, Matplotlib is on the other end. I would put Holovis in the middle. There are shortcuts, you can do very quick plots, but at the same time still have the flexibility of Matplotlib.
Nice.
Fantastic. Another question just came in about the ease of deploying a panel dashboard on the web using Heroku or AWS.
So I haven't tried it myself. I would say that if you're, it looks like from the instructions here about serve. So in the panel notebook, once you're happy with the app or dashboard you have built, you can annotate it with servable. In the notebook, this annotation has no effect, but it will later indicate to the panel serve command that you want this particular component to be served. If you then go to the command line and run panel serve, this code cell in the notebook will be executed and the resulting dashboard will be available as a web server. So I have to imagine that if you deployed a Jupyter notebook with panel installed and all the libraries that you require for your Python notebook, and you ran this command, that would work. But yeah, I haven't tried it myself. I don't know. Felipe, have you tried that?
I never deployed an app myself, but it is possible. However, it's not as easy as the Rshine one, because the Rshine one, they have their own server. You can just push it and it works out of the box. For panel, you need to serve that yourself. So yeah, you can use Heroku, you can use AWS, you can use your own server. But again, I never use it.
I also wonder too, like sometimes I wonder about what's the use case, because if you want to, it's pretty easy to share notebooks with Binder Hub, right? So then if you are able to run the panel in a notebook, it could be just as easy.
Yeah, that I've done. It's just slow because you need to fire up the whole environment and everything. When you have your panel without a kernel, like without safe data, it's faster.
Yeah.
I believe Emilio deployed one. Maybe he can comment on that.
Hi. Sorry, I posted a comment there that I deployed a panel app via Heroku. And the question was whether it was easy. And my answer is that, well, easy, the meaning of easy can vary. It's not completely straightforward in that it involved, because of the, I was using the cheapest Heroku plan, and I needed a Conda environment that had a lot of things. I end up using a Docker image. If you are familiar with Docker, it's not hard at all. I'm not sure what else I can say. Daria asked me if I could share the example. I'm going to share the link to the GitHub repo that has the notebook and the URL to the actual app that is hosted on Heroku. And if many of you, if more than 5 of you try it, you'll probably bring it down, because the audience is supposed to be a small research group. But don't worry about that.
Yeah, there's more information about launching a server on the command line here, but maybe not so much about deploying it. question for Felipe. Do you know if Oleum should still be a part of this tutorial?
That's a good question. I don't think so. So just some history. Folium was probably the first sleepy map software for Python. It's wraps leaflet, and it's relatively easy to use, and there are many plugins. However, once Jupyter ecosystem moved to Jupyter Lab, they changed the way they wrap JavaScript libraries. So we lost the way to do two-way interfaces without actually doing an npm install of leaflet. And we decided to not do that. And then IPython leaflet came into play. It's not there yet, but it has all this functionality. And Holovis has the same functionality as well. So no, I don't think it should be on that tutorial. Right now, it's a niche package for people who want to output an HTML and with sleepy map on the web with just an HTML file. It's not really a good answer. But
Yeah.
like Folio is my child, so I don't see it die, but it will die soon.
I think it's still being used by people for exploratory geospatial analysis in a Python notebook environment.
Yeah, like even the Streamlit folks, they contacted me several times in the past. They want to make it part of their dashboards. And I just told them, you have better stuff out there. Don't use it. Make newer stuff.
It looks like there's one more question about doing cross-filtering between plots, like with Plotly and Dash.
Cross-filtering between plots. Can you read the question?
So yeah, is it possible to do cross-filtering between plot, like with Plotly and Dash? So I would think this is kind of select a value and both plots would change based on that value.
Oh, yes. I believe you can do that with param. So param is where you can configure parameters for different, I assume that if both of the visualizations that we're talking about are created with like HoloViews objects, that they could both rely on something that's using param for user modifiable parameters. So if you use this library to create whatever thing you want to change to update both of those visualizations, that should work. Okay, since we're almost at time, I do want to plug a couple of things. So obviously these notebooks are on the OHW tutorials thing, and if there's any feedback or anything, feel free to post issues there. There's in terms of doing dynamic tiling of large raster data sets, there is a development seed library called T-Tiler that's gained a lot of popularity. So T-Tiler is basically a way to, if you have like cloud optimized geotiffs that you've stored somewhere and you want to do dynamic tiling and visualization using familiar APIs like OGC APIs like WMTS and XYZ, you can just use, this went to Mosaic JSON, but you can just use the docs here to see what OGC, like, so like tiles endpoints, you just basically pass a cloud optimized geotiff and it will do dynamic tiling of those cloud optimized geotiffs. So if you want to learn more about that, feel free to reach out to me or Vincent, who wrote it. Yeah, and then the other thing is, just as I mentioned at the top of the tutorial, is that myself and I'm sure some other folks on the call are interested in sort of creating more cloud optimized data and services. So one of the reasons why I've stayed involved in, wanted to be involved in Ocean Hack Week was just to hear more of the science use cases. So if you have a specific science use case where you're interested in creating a cloud optimized data set such as ZAR, feel free to reach out. I'd love to hear more from you. Cool. All right. Thanks.
Okay, great. Thank you, Aimee. That was excellent.